Hello, everyone. What I want to do is go over the homework 5 that you guys handed in Friday night. Most people did okay. There's definitely a few people who didn't really get it. Um, yeah, I'll go over it. And I'm in my office on campus, and they turned off the AC, so it is hot in here. So that's why I'm wearing a sleeveless shirt. Probably, if I had to guess, 80 degrees in here, 85 degrees. But anyway, so without further ado, let's get to it. So just use the formula. Um, so we have 175 is S3N J, and if you forget the formula, you can always just draw a time diagram and basically rederive this if you need it. Um, I don't remember if I used it on the exam FM I took, which was a little over a year ago. So it was June 2023. But as in case you do, yeah, I mean, I would probably just rederive it very quickly. What the formula is 1 plus j to 2n Sn. Really, if it's 3n, you would just break it up into 3 blocks of n, and n. And then, so yeah, and then like each block, the first block accrues 2n periods of interest, hence the 1 plus j to the 2n. The second block accrues n periods of interest, hence the n, 1 plus j to the n. So I'm basically doing what I did in the video and deriving this. So that way of thinking is extremely important. But whether you will actually use this on exam FM in literally your exam, I'm not sure. You might. Anyway, right. So each one of these is 25. So just plop that in. And then set this to be x, so that this is x squared. 1 plus j to the 2n is 1 plus j to the n squared. So, sorry. Really make this as annoying as they could. Anyway, so this is 25x squared. Move this down. Go a little quicker for b. Plus 25x plus 25. So anyway, basically, yeah, 175 is equal to this. So solve for x. Rather, it doesn't really matters much, but yeah, 175 is equal to this. So x is, I technically did not say that, yeah, I mean, technically, I did not say you don't have a negative interest rate, so theoretically it's possible, but I didn't take off. I think only one person wrote the possibility of a negative interest rate, and I did not take off because n could be even or odd. I should have mentioned j is positive, but anyway, only one person, even gave that possibility. So x is j, sorry, x is 2, and this is 1 plus j to the n. So yeah, let's use SNJ is 25. So 25 is SNJ. 1 plus j to the n minus 1 over j. So that's 2 minus 1 over j. So j is 21 over 25, a nice reasonable interest rate, 0.04. All right, so B, similarly use the formula. Gotta use quadratic formula, but that's fine. So 4.25 is SMJ. So this is and if you forget this formula, you could just draw a time diagram, break it up into, I guess, well, it's not really three annuities, but just do the n-2 payments, and then do the last two payments just literally separately. So, yeah, so it's SN-2J. The second to last payment accrues one period of interest. Right. So this is this accrues two periods of interest. 1 plus j squared. So this is x squared. I'm not going to go to blue. So x is quadratic formula. And if you're going to take exam FM anytime soon, definitely remember your quadratic formula. Some people got it wrong. I mean, if you're not an actuary major, who cares? But you don't want to fail exam FM because you forget the quadratic formula, and you will definitely need it. You will definitely need quadratic formula for exam FM. Stupid, but you do. Okay, and I don't write the exams. All right, so another reasonable interest rate, about 5%, 0.04904. Okay, number 2. So Catherine deposits 120 into an account at the beginning of each 4-year period for 40 years. So let's do that. All right, so I'll do it like this. I forget how I did it in lecture. It really doesn't matter. So this is in 4-year period. So this is like year 4, 8, et cetera, et cetera. Whatever. All right, so payments at the beginning of each 4-year period. So 120, 120. Nothing here. So it's still a total of 10. So let's say J is my 4-year interest rate. Definitely easiest to just focus on your 4-year interest rate and then convert to a 1-year interest rate. I mean, you can work with a 1-year interest rate here. It's just more annoying, really. All right. So just yeah, it's 120. So 10 4-year periods, S10 payments at the beginning of each year. So 120, 1 plus j to the 10. This one, j. It doesn't really matter if you forget this because it'll be in the same. You'll have the 1 plus j for the other one also. Good to write it. Okay. The accumulated value at the end of 40 years is 6 times accumulated value at the end of 20 years. Never hurts to draw another time diagram. Maybe on exam FM, and even then, I mean, maybe I would skip it, but I mean, how long is this really taking me to do? So again, this is 4-year periods. This is 20 years right here, payments at the beginning of each year. So the accumulated value is same thing, except both 5 periods. 5 20-year periods. J is, remember, my 4-year interest rate. All right, got plenty of room, that's good. Always an issue when I'm doing this, if I have enough room or not. All right, so we are given this accumulated value here, or sorry, this accumulated value here over 40 years, and I'll cancel a whole bunch of stuff now, of course. Is 6 times well, let me do it like this because I don't want to do a million brackets. So I'll just do it's 6 times this whole thing here. So I'll just do the 6 times 120 and one bracket here. I mean, it really should be another bracket, but that's just, I don't know, it probably is going to look more confusing than anything. So probably not a good idea. I want plus J. All right. Second. All right, so the 120s cancel, the J's cancel, the 1 plus J's cancel. So I'm not going to rewrite stuff. I mean, I'm not going to erase, I'll just rewrite. All right, so simply, I'm running out of room, but that's fine. So this is 6, bracket here. All right, so this is a different color maybe. This is my X. So this would be X squared. That's definitely bright. All right, so this means X squared minus 1 is 6X minus 1. And yeah, I should have said a positive interest rate. I don't think anyone, I think some people said, well, the 0 interest rate's just weird, doesn't make sense. Technically, you can have a 0 interest rate, I guess, in theory. But anyway, so you're going to get X is 5. Just from here, just factor after simplifying stuff. And remember X, sorry. Remember X is 1 plus J to the 5th. So that means J is 0.37973. Maybe X, I mean, whatever. You can call this whatever you want. I guess technically this is X here. So this AV, just literally plug in J is 0.37973. I'll do this in green, I guess. 758,434. All right. Now, a bit of practicality. So you really need to just think about what this is saying. So every 5 years, I'm growing by 38%. So when you solve for your annual interest rate, you're going to be growing by a lot less every year. Okay, you know, I mean, and it's going to be a lot less. If you're growing by 38% in 5 years, it's just going to be, I mean, if I guess I can't really guess. I'm not sure there's a point in guessing what that would be every year, but it's definitely going to be a lot less growth every year. So if you get an answer, even like 20% per year, that makes no sense. You're not going to grow 20% per year for 5 years and end up growing 38% in 5 years. That just, or sorry, 20% per year for 5 years. That does not overall correspond to growing by 38% intuitively in 5 years. I mean, if you did grow 20%, it's 2.5. I mean, you're growing by 250% almost in 5 years if you grow by 20% every year. So, anyway, I, yeah, so if you want to do 1 plus I, yeah, say I is my annual interest rate. So this is my what is this? Yeah, sorry, this is my 4-year interest rate. So let me see what that is. 0.087, basically 0.0838. Squeeze this in. Yeah, it makes a lot more sense. Growing by 8.38% every year is the same as growing by 38% every 5 years. Right. Sorry, every 4 years. Every 4 years. I think I even said 5 years before. Yeah, mixing up 4 years and 5 years. Sorry about that. But anyway. So yeah, actually, if you grow 20% per year, then in 4 years, you're just about doubling your money. So it's about 207% growth every 4 years. All right. All right, so for this problem, you can guess the answer and get it somewhat close and get 7 out of 10 right in this course. You can't guess it on Exam FM. So, and just draw the time diagram and read off of what it says. It's really not, in my opinion, these annuities, like there's only so many weird variations of annuities you can get. So if you really just draw the time diagram and not super slowly, but if you just take your time to some degree and just think about what's going on, you're gonna get all these right, basically, with enough practice. I know when I took Exam FM, I was very happy when I got an annuity problem like this, even if it's a little funkier. And I'm pretty sure like I got like 15 of these out of 35, just totally right. Yeah, it really helped. Because first of all, it's the beginning of the 3rd year, that is T equals 2. Beginning of the 5th year, T equals 4. 200 at the beginning of the 2nd year, T equals 1. 200 at the beginning of the 4th year, T equals 3. Beginning of the 1st year would be T equals 0, because the 1st year is 0 to 1. 2nd year, 1 to 2, etc. But I'm not telling you there's anything at the beginning of the 1st year. So, okay, so this is every 2 years. So you don't really have to draw separate time diagrams, but if it helps, do it. You got plenty of time in this course, even taking this in person. Not sure I would spend the time on Exam FM, but doing separate time diagrams. But anyway, so if you wanna, I'll just do it. This is 1, 3. I'll do one more, 5, doesn't matter. So this is 200. So periods are every 2 years. So So 2 years of growth corresponds to the growth factor of 1.0816. So subtract 1.0816. So if you grow by 4% per year, you are growing by 8.16% every 2 years. Those two things that I just said are they mean exactly the same. Okay. So this one, the easiest thing to do is an annuity due. And remember, because the way if you do it like this, payments are at the beginning of each time period. So yeah. And remember the new present value formulas always give you the present value at the beginning of the first payment period, which is 1 to 3 here. Maybe I should say always one more time. But yeah, it's the beginning of the first period. So it's 200 a double dot infinity 0.0816. Discount this by 1 year. I'll have to do it here. I hope I don't run out of room. I'll erase if I do. I would normally put it up here, but I'm running out of room. And I'm discounting by 1 year because I need to go from 1 to 0. Present value always means, find the present value always means actually at t equals 0. Right. I'll plug in for the formula in a moment. Yeah, I mean, writing all this down is kind of laborious, but just thinking like this, it's pretty quick. You had to do this on exam FM. So 200, 1 plus 1 over 0.0816. 1.04 to the minus 1. And this is going to be equal to 2549.02. And for the other one, it's a lot easier, I would say. 0, 2, because this just fits immediately as an annuity immediate. So it's 100. Payments are every 2 years. So the first payment period would be 0 to 2. So if we think of this as annuity immediate, payments are at the end of each payment period. So it's 2, 4, 6. Then the present value formula gives me the present value at the beginning of the first payment period, as always, again, always, which is t equals 0 already. So this is already 100 a infinity 0.0816. No need to discount anything. And this is 1.22549. Add these two up that I circled, you get 3,774.51. Right. And so I will, I have to get the calculator. I don't really need it for 4, but I will need it for 5. And you definitely need the calculator for 5. That's the whole point of 5. I know most math courses, it's, don't use the calculator, but this is not most math courses. This is an exam FM prep course. So you definitely need to know how to use the calculator. Yeah, and freaking annoying because Texas Instruments thinks people are going to steal this and pirate it and do all kinds of funky things. So I have to have a little dongle here even to freaking have an exam. Oops. Okay, I'll plug it in a minute. I only have one USB port here. Okay, not a big deal. All right, so number 4, two annuities in perpetuity have a common present value of 2,000. A lot of people did something really weird here, and I honestly don't even understand. Like, I don't understand why people thought this way. So this, you don't really even need to draw the time diagram, because let me just do sorry. First, so the first annuity payments of 1,000 at the beginning of every 4 years. Okay. So this is just a plain vanilla annuity. It is in perpetuity, that's fine. But it's the beginning of every 4 years, so it's an annuity due. I'm telling you what the time periods are. It's every 4 years. So, I mean, again, you don't have to draw a time diagram. It really doesn't make any sense. Or it's just, there's no point. I will do it anyway. Just to emphasize my point. So let's say J, we don't know what this is. We're gonna find it. It's kind of the point. Let's say J is my 4-year interest rate. Okay. Yeah, so for 5, just because I can't write stuff down when I have the calculator plugged in, it's gonna be a good review on using the memory keys. I personally do like to write stuff down. It's just a psychological thing. Like on exam FM, I did write probably more stuff down than I needed to, rather than using the memory keys. But again, it's just like I don't know, like a security blanket kind of thing. If that makes any sense. Anyway, so present value is 100 A infinity double dot J. Well, we're given this is 2,000. Common present value of 2,000 right here. Oops. This is big as usual. Okay, let's see, double dots. Okay, so this is 100, 1 plus 1 over J. So literally just solve this here. 2,000 is 100, 1 plus 1 over J. So J is 1 over 19.0526 degrees. Okay, so let's say I. So this is kind of to throw you, not really throw you off, but so the point is, if they have the same effective annual interest rate, then there's just the growth for each annuity, or the rate that we're pricing each annuity at is the same. It doesn't matter really what interest rate. They're all, it's like we're all dealing with equivalent interest rates here. So, um, you know. All right, so you can now do this one of two ways. So maybe it's best to do, let's say it's J1. Let's say J2 is my 6-month interest rate. You can save time and just directly connect the 6-month interest rate to the 4-year interest rate. So compound 6 months of growth 8 times to get 4 years of growth. Okay, and just want to double check this. Yeah, you get a really small interest rate, that's fine. J2 is 0.006432. So growing by 0.643% every 6 months is the same thing as growing by 5.3% roughly every 4 years. Or you can just, as I've done before, go use the annual interest rate as an intermediary. I'm not sure if that's really necessary, but so if I is my equivalent effective annual interest rate, then, well, compounding that 4 times, it's the same thing as 5 years of, sorry, 4 years of growth, and 4-year growth rate is 1.05263. So I is 0.012906. And right, so compound 6 months of growth twice to get 1 year's worth of growth. Yeah, I want to emphasize, I think this is a little silly. I would personally just do this here, just compare 6 months of growth to 4 years of growth. But either way, get the same answer. 1.05263 to the 1/8, basically. 0.006432. All right, I'm not going to draw a time diagram, but the second one makes payments of X at the beginning of every 6 months. So again, it's a plain vanilla annuity. Yeah, plain vanilla annuity. So just plop into the annuity formula. So they both have a present value of 2,000. So let me move that over. So it's X, A, infinity, double dot, J2, 1 plus 1 over 0.0064332. Yeah, so you have 2,000 here, a number times X. So just solve for X, 12. That's weird. 1278. All right. Okay, next one. I would draw a time diagram here. And I took off 3 out of 10 if you forgot to appropriately discount, because it's a big deal. I mean, it just totally screws things up and you get a totally wrong answer. Okay, so 1,000 at the beginning of each year for 15 years. Nothing at t equals 15. So here interest 0.065. Here we're trying to figure out what it is. So just break it up into 2 annuities. Okay, so I got my first 10 here. So the loan is 10,000, so that's the present value. So it's 1,000. Double dot. It's at the beginning of each year, so it is an annuity due. And you don't want, I shouldn't say again, because I don't think I mentioned it, but you really don't want, you really got to be careful with annuity do's versus annuity, I should make a joke, don'ts, but annuity do's versus annuity immediates. Um, Actually, I think I saw an ad on, it was Ion TV, maybe even annuity do's and don'ts. But anyway, just annuity do's versus annuity immediates. You could very well have an answer in Exam FM where there's a multiple choice letter that has the answer that would be correct if you screwed it up and did annuity immediates. So again, you just be careful. A lot of people did not treat this as an annuity annuity do. And just that little attention to detail is very important for Exam FM. It could mean the difference between passing and failing. Okay, so that takes care of that. Nothing really to do there. No pun intended. So erase this. All right. Right. So now we have this here. Okay. 1,000. Now the beginning of my, I guess I can even, well, put 11 here. Squeak in this 1,000 here. So this is annuity due. Payments are at the beginning of each payment period. First payment period 10 to 11, last payment period 14 to 15. We don't know what the interest rate is, 5 payments. But the beginning of the first payment period is t equals 10, and we always have to discount and bring it to t equals 0. Remember, always, 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 the annuity formulas give you present value at the beginning of the first payment period. In this problem, it dramatically changes the situation. So I have to discount by 10 years at 6.5%. I mean, that's dramatically makes things dramatically different. Okay, so yeah, so I'm gonna have to unplug my digital pen and pad and plug in my calculator. Bear with me a second. Okay, let me get back to it. Move this over here. Okay, well, this equals 10,000, so just remember that. All right, so the first thing I would do is do this. So clear TVM. Let's go to begin mode. All right, so I'm in begin mode. I cleared TVM. I can just plop everything in. 1,000 payment 10, and does not matter what order I put things in. Remember, always as a percentage, you input your interest rates as, and it'll spit out a percentage as an interest rate. So compute present value. All right. So I'm going to just take, so I'm going to subtract this whole thing from this, or yeah, I mean, I'm going to bring this to the left-hand side. So just leave the minus here and add 10,000. And I'm going to multiply by 1.065 to the 10th to isolate. So I'm using my mouse here, but to isolate this here, that's why it's awkward and weird. I'm using my mouse here, but yeah, I'm going to multiply both sides by 1.065 to the 10th to get rid of this, to isolate what I just circled. All right, so yeah, let's multiply by 1.065 to the 10th. That's a much bigger number, almost double. So if you, yeah, you get a totally different answer. I forget what the answer is. I think it's something like 20%, like 15 or 20% for I if you don't remember to properly do this discount by 10 years. But anyway, all right, so now we have, yeah, basically, what I'm circling equals what is here, right? So, yeah, that's the present value. 1,000, you can divide by 1,000 if you want, doesn't matter. 5 and compute IY, and you get your answer, your proper answer, 6.8357%. Okay. So yeah, got any questions, let me know. Homework 6, remember, is due Tuesday night. So hopefully this helps you with homework 6. And yeah, it's almost, we're 2/3 of the way through almost. Exam 2 is going to be put up Friday afternoon. It'll be due Sunday. So I'll get on that soon and put it up definitely by Friday. So and I'll definitely get your I'll do your homework 6 grades probably Wednesday, maybe Thursday, but probably Wednesday I'll grade it all and put a homework solution video for homework 6. So all right, so long, take care. We're getting there, getting to the end.